In this video, we're going to talk about arithmetic sequences only. And there's a difference between sequences and series, and the book we use doesn't clarify that. A sequence is it's a list of numbers. It's just a list. Whereas a series is where you add them up. So you're going to get the sum. So all we're doing in this video is listing numbers or finding the certain term in a certain sequence. Here's your formula we saw in the previous video that you already came up with, and here's our definitions that you already knew from the previous video. So the first thing we're going to do is find the indicated term for each of the arithmetic sequences. And I have my little list here. So we have, so for example, number 1, we have ace of 14 is what we're looking for. And we know that ace of 1 equals 4, and the common difference equals 6. So basically, they know that the first term, and we know the common difference is 6. So the second term, if you were just to list this, the first term is 4. So the second term would be what? 10. And you can go all the way and do it that way, keep adding 6. You get to use a calculator, so you could do it that way. But the easier way is to know your formula, especially when you're taking your SAT exam. So we are looking for ace of 14. And I'm going to plug it in my formula. Ace of 1 is 4 plus my total number. Now, these two numbers will always match up. So here, these two always match up. So basically, since I have a 14 here, this is what goes here. So it's 14 minus 1 times your common difference, and our common difference they gave us is 6. So you get 4 plus 7 times 6, no, times 13. I cannot subtract as usual. 13 times 6, and that gives you 82. A lot faster than if you're trying to list each term all the way up to the 14th term. Okay? Now, here's one. We want to find the 12th term, and we know the first term is negative 4, and our common difference is negative 2. So I plug it in my formula. Ace of 12 equals my first term plus my total number of terms, which is 12. Subtract 1 from that and multiply by your common difference. And that yields negative 4 plus 11 times negative 2, and that gives you negative 26. So my 12th term equals negative 26. Okay? Now let's do different kind. Let's find. They give you they want ace of 12, and they give you a list of numbers. So the list of numbers is 4, 10, 16, 22, ... Yes, of course you can keep. What is our common difference? We know our formula is this. You really know this formula because on the SAT they probably won't give you any harder than this. So we know we're looking for ace of 12. We know my first term is 4. So this is going to be 12 minus 1. And all you need is your common difference, which is, what do we keep adding here? Yes, 6. So it's 6. So you get 4 plus 11 times 6, which yields 70, I believe, which equals 70, yeah. And we can do, let's do one more negative. So we have, we want the 21st term, and for 10, the sequence 10, 6, 2, negative 2. So ace of 21 equals your first term plus 21 minus 1 times your common difference. In this case, our common difference is negative 4 because you're going down in the sequence. And you add all this up and multiply. So that's going to be 20 times negative 4, which equals negative 70. Okay? Now, you also might have a question like find the missing term. So say I have 5, 1, 2, 3, negative 3. So I have to use the formula and find the missing terms in here. So what I'm going to do is use my formula. I know I have 5 terms. So if I write ace of 5 equal ace of 1 plus 5 minus 1 times my common difference. Okay, there's that. Now, I know my first term. I don't know my common difference, but I do know my fifth term. So my fifth term is negative 3. My first term is 5. And then I have plus 4 times d. So we're going to solve for d. And when you solve for d, we're going to get, I'm going to subtract 5 from both sides. So I get negative 8 equals 4d. So d equals negative 2. And then from here, all you're going to do is subtract 2. So 5 minus 2 is 3, 1, negative 1, and negative 3. We can do one more of those. Let's try 2 more of these. So we have negative 7. That's a 7. 1, 2, 3, 1. So my last term, this would be ace of 1, ace of 2, ace of 3, ace of 4, ace of 5. I have 5 terms. So ace of 5 is 1 equals my first term plus n minus 1. My n is 5. So that's going to be 4 times d. Solve for d. So you have 8 equals 4d. So d is 2. So you just kind of add 2, and you're going to get negative 5, negative 3, negative 1. And that's that. You might get one where you want to fill in, let's say, 1, 2. You have 42 here, and you have this, and 60. So how would you do that? The way I would do it is when I'm using my formula, I'm really looking for the common difference. So I would just look at this as my first term, and this is my last term. So I would have 60 equals 42 plus, and since I'm only looking at this right now, I only have 3 terms. So that's going to be 3 minus 1 times your common difference. Solve for your common difference. So what's 60 minus 42? That's going to be 20, so 18. So 18 equals 2d, so d is 9. Let's see if that works. So add 9 to this, you get 51, and you have basically your fourth term here. Now, to get these 2 terms here, I'm just going to subtract 9. So when you subtract 9, you're going to get 33, and you're going to get 24. So that's how you can work those. Okay? Now the next section, let's do let's just do one more set here. We're going to complete the statement. 97 is, is the what term of -3, 1, 5, 9, and so forth. So, we're looking for n here, okay? We don't know what term this is, so I'm looking for n. And what I'm going to do is let this be I know my common difference is 4, so I can fill in my formula. This is the last term we're looking for. So you have 97 equals -3 plus n minus 1 times my common difference is 4. So I'll clean this up a little bit, and I get 97 equals -3 plus 4n minus 4. So I'm going to add 7 to both sides, and I get 1. Add 7 to this, we get 104 equals 4n. And so we're looking for n, you divide by 4, and 4 goes into this 2 times, so this would be 26 equals n. So 26 equals n. That's your nth term. All right? And we can try another one. And so this will be the last one of this set. We have -10 is the blank, so nth term of, we have 14, 12, 5, 11, wait, I'm copying this down wrong, 12.5, ooh, geez, I don't like this one, 11, and 9.5. So our common difference is 1.5, right? You keep subtracting 1.5. So we have -10 is the last term we're looking for, equals our first term plus n minus 1 times your common difference, which is -3/2 or 1.5. Okay? So we're going to go ahead and take care of this. Plus, I'm going to subtract. I'm going to distribute here. So you get -3/2 n plus 3/2. And then you're going to solve for this. And you're going to get, if you subtract the 14, you get -24, and you're subtracting 3/2 from that, equals -3/2 n. And so this will be -48 over 2 minus 3/2 equals -51 over 2, which equals our -3/2 n. Multiply both sides by -2/3. The 2's cancel, and that gives you 17. Because you have 51 over 3 equals 17. Okay, that's basically it for the sequences.